In this video, I want to give you another tool to solve quadratic equations. I want to show you how to solve quadratic equations by using factoring, and I also want to show you how to solve it by doing something called completing the square when you cannot factor. All right, so what about this one? Suppose I had x squared plus 5x plus 6 equals 0. All right, so the first comment I want to make is that if you don't have an equation that has 0 on one side, go ahead and make it so. So for example, let's say that the original equation was given to you this way. You could have all kinds of mishmash ways that this could be given to you. So what I would do if I had that, what I just wrote at the top of the whiteboard is, as I said, try to get a 0 on one side. So I would add 5x to both sides in that case, and so then I would have x squared plus 5x plus 6 equals 0, just like I wrote at the bottom of the screen. All right, so the factoring trick I'm going to show you is only going to work if you have a quadratic equal to 0. Okay, now that we have that square, go ahead and factor the quadratic. In this case, you will get x plus 2 and x plus 3, and those two binomials, as they're called, will provide the correct middle term. If you FOIL that out, you'll see. Okay, so there you have it. There's the factored form of our quadratic equation. Now, in order to continue, I'd like to bring something to your attention. We're looking at a product of two blobs, two pieces, two binomials, and the product is equal to 0. Now, can you think of some examples of products that are equal to 0? Let's just brainstorm. Think of a couple. How about 5 times 0? That's equal to 0. How about 0 times 10? How about 0 times minus 4,831? How about 1 billion, 10 to the 9 times 0? So those are a couple of examples. Did you notice that every example you're multiplying by 0 somewhere? If you want a product to be 0, you have to multiply by 0 somewhere. Okay, we're going to use that when we solve the blue factored quadratic. The only way that that product could be 0 is if one or both of those binomials, those blobs, are 0. So either x plus 2 is equal to 0 or x plus 3 is equal to 0. Okay, so let's go ahead and solve both of these. And so we get x equals minus 2 or x equals minus 3. And so those are the two solutions. Remember I said that you can have two solutions for quadratics? So here's an example where you have 2, and we found it by factoring. Okay? So review factoring if that's not coming to you, how I did that. All right? Let's do one more example of factoring. So maybe one with a negative this time. So what if we had, let's say, all right, and so factoring this gives x minus 12 multiplied by x plus 1. So x is equal to 12 or minus 1. Those are the two solutions. Okay? And you'll do more of those. You'll get practice with those on the homework. All right. Now, what if we couldn't factor it? Wouldn't that be a real bummer? All right. So let's talk about that. What happens if you factor it? What happens if you can't factor? So for example, let me make a slight change to this one. X squared minus 11x minus 11 equals 0. Okay, so try to factor that. Maybe you think x minus 11 times x plus 1. Maybe x plus 11 times x minus 1. All right, no matter what you try, and I don't think there's any more options besides, whoops, hold on just a second. I don't think there's, besides these two options that I'm writing currently, I don't think there's anything else you can try. So get this idea out of your head that you can always factor everything. All right, some things cannot be factored. Let's get that clear. Okay, so what do we do in that case? Well, I have another trick up my sleeve I'd like to show you. Okay, so what if we had the following? X squared plus 4x, let's say minus 2 is equal to 0. Okay, there is an example of something that you cannot factor. All right? So, however, I'll show you why I'm going to do this in a second, but let's pretend that somehow somebody told you to add 6 to both sides. Don't ask me why, just bear with me. Okay, then you would have, let's simplify, x squared plus 4x plus 4 is equal to 6. That doesn't look like much of an improvement. Okay, however, try to factor the left side now. If you factor that, you'll get x plus 2 squared. You get a nice perfect square equals 6. Well, we know how to factor this, or at least I hope you do. What you do is you take the square root of both sides. Okay, so that means x plus 2 is equal to either plus or minus the square root of 6. So x is minus 2 plus or minus the square root of 6. You see that? So there is a way that you could solve a quadratic even if you can't factor the dumb thing. All right? Now, in order for this trick to work, you have to be able to get a perfect square. It's not going to work if you factor it any old way. You can't just add any number to both sides and then factor it and get some random factoring and everything's going to be great. It has to be a perfect square. Both of the parenthesis blobs, both of the binomials have to be the same. Okay? So I know what you're asking, or I know what you're wondering. You're wondering, okay, well, how do I know what to do so that I get exactly a perfect square? All right? Well, there's a pattern that I want to bring to your attention. The pattern is that if you have something that's a perfect square, let's FOIL out a couple of perfect squares for a second. Maybe you'll be able to see the pattern on your own. So the first one, x squared plus 2x plus 1, x squared plus 4x plus 4, x squared plus 6x plus 9. And let me just in general, let me add a k to represent every, so I don't have to do an infinite number of examples. And then whatever you want to see, just replace k with that number. So this would be x squared plus 2kx plus k squared. All right? Now, notice looking at the coefficients for a second, notice that the last coefficient is always the square of half of the middle coefficient. Okay, the last number is the square of half of the middle coefficient. All right. So for example, on the first one, what's half of 2? Half of 2 is 1. 1 squared is 1. See that? Let's do the second one. What's half of 4? Half of 4 is 2. 2 squared gives 4. Next one. What's half of 6? Half of 6 is 3. 3 squared gives 9. And then the last one, what's half of 2k? Half of 2k is k. K squared, well, that's k squared. See that? That's the trick you want to use to figure out what that you need to make that last number. So going back to the original one that I did here, I looked at the 4 and I said, okay, that means I want the last number to be a 4, but it's not a 4, is it? It's a minus 2. What do I need to add to minus 2 to turn it into a 4? That is how I figured out that it has to be a 6. You see that? Okay, let's do another example. Here's an example that cannot be factored. Okay? Tell me, can you figure out using what I just said what we wish the last number was, what we wish we could turn the minus 3 into? Okay? So look at the middle coefficient, the 6. Cut it in half. What do we get? We get 3. And square that, we get 9. So what can I add to minus 3 to turn it into a 9? How about if I add 12? Okay, and then lo and behold, as I said, perfect square. Square to both sides. That's, if you want to play with the square root of 12, that's 2 root 3. Okay, so x is equal to minus 3 plus or minus 2 root 3. Look at that, 2 answers again. Okay? What if the middle number is negative? Doesn't matter. Just do it the same way. Chop it in half and square it. Okay? What if there's a coefficient in front of the x squared? Let's do that example. So what if I had something like 2x squared plus 16x minus 10 equals 0. Okay? Now, because you have a 0 on the right side, and because you could multiply or divide 0 by anything, and you'll still get 0, well, besides, except for division by 0, let's just get rid of the coefficient in front of the x squared with a division. So, in this case, we have a 2 in front of the x squared, so divide everything by 2. That's it. Problem solved. See that? So now you can solve this blue one the same way you solved the purple one. In this case, you'll want the last number to be 16. See if you can figure out why. Okay? So whether the first one's negative, whether you have a coefficient in front, I've told you how to handle those cases. What if you had fractions? Okay, again, you just do it the same way. So like if I had 1/3 x squared plus 2x minus 5/2, something like that. So you still would get rid of the coefficient in front of the x squared. In this case, you'd want to triple everything. So minus 15 over 2 equals 0. And then you would still chop the middle number, middle coefficient in half, get a 3. So you really wish the minus 15/2 was a 9. So let's add to both sides, let's add 9 plus 15 over 2. Okay, so then that would give x squared plus 6x plus 9 equals 9 plus 15 over 2. And then you could go ahead and you'd get x plus 3 squared. And then if you like, you can combine the right side into one fraction. Let's see, 9 is 18 over 2, so that's 33 over 2. Okay, so putting it all together, take the square root of both sides, and so I'll write the answer on the left side. So x plus 3 is equal to plus or minus the square root of 33 over 2. So x is minus 3 plus or minus the square root of 33 over 2. All right. Now, there is another advantage to completing the square. What it allows, and this is an additional point. Now that I've shown you how to solve quadratic equations by factoring and completing the square, this is one extra unrelated point. Suppose that you had a quadratic, generic quadratic, something like this, okay? And suppose you wanted to plot that. Suppose you wanted to know what the plot, by the way, will be what's called a parabola. It'll be either a hill or a valley, something like this or something like this, okay? What if you wanted to know the top of the mountain, the blue mountain, or you want to know the bottom of the position of the bottom of the red valley, okay? Graphing polynomials, it'll often be easier if you first complete the square, okay? So instead of trying to graph the quadratic function that I wrote there, suppose you instead wanted to graph this one. Okay, now because you've completed the square, that's going to give you useful information. In this case, you know that the top or bottom of the mountain is going to be where the parenthesis blob is 0. Okay, so in this case, it's going to be at 2, and if you plug in 2, you'll get y equal to 1. So 2, 1 right there, and then you can plug in other numbers to see that this is going to be a valley. Okay, but look at that. So completing the square gives you the max or the min of the function. Okay, that's a little extra bonus if you learn how to complete the square.